Hello everyone, welcome back to another Stat385 video. So we are covering data transformation and tidy data. And in this video, we are going to talk about visualizing data using ggplot2. I'm going to point you to the data visualization chapter in the R for Data Science book, which I think is a pretty nice way of laying this out. In particular, I like how they have this ultimate goal of a plot that they're using ggplot2 to create, and then are going to build up ggplot from the bare minimum, from nothing, to get you to point you how to build this plot. So it's something that I would recommend reading. I'm going to do something somewhat similar with just a different example. Well, I'm not going to build up to any particular point, but rather just display some of the foundational, widely used concepts of ggplot that are fairly widely used. Okay, so first we're going to need ggplot installed. Install packages. ggplot2, I already have it installed, but this is what you would run if you don't have it installed. And same thing with the tidyverse. I'm going to load everything, and then I'm going to work with this miles per gallon data set, which displays data about the fuel economy data from 1999 to 2008 for 38 popular models of cars. Okay, so we can see, and I'll just load in the data. You see like manufacturer, model, displacement, which is engine size, year, cylinder, number of cylinders, type of transmission, drivetrain, city and highway fuel economy, fuel type, class, whatever. Okay, so in this data set, we've collected a bunch of information on different cars, and we may want to visualize some relationships. So we're now going to talk about doing that using ggplot. Okay, so first thing that we need to do is specify a data set that we would like to work with. Okay, so I'm going to run this. It's going to do nothing. It's just creating an empty canvas for us to work with. But you can see that by running this, we've switched from what we were viewing earlier to the plots tab. Okay, so now let's go back to the website here and point you to this cheat sheet, which is nice. Okay, pretty overwhelming, contains a lot of information, over 2 pages, but it's also a lot of useful information that is widely used in practice. Okay, but what we're gonna show here is this part, or what I want to highlight now is this part, because this is the basic template that you're going to follow when making or when visualizing data using ggplot. So the first thing, we've already done this. We have data equals data, and then we have specifying geometries to display certain information in the data. This is required and then not required, but can do things to make more interesting visualizations that may be necessary to communicate specific things to an audience that would require that. And we'll get into that as we go. Okay, so basic layout. Oops, I'm going to get rid of that because I am going to scroll back and forth quite a bit. Okay, so I need a geom function. Most basic one we can do is point, creating a very simple scatter plot. So now what I need to do is specify a mapping. So a set of aesthetic mappings created by aesthetic. Okay, so nice, gives us a little bit of information. And I want to specify an aesthetic. And what I'm gonna do is explicitly specify both the axes for the plot and the variables that I want to display in those axes to plot in this scatter plot, just displaying point information. Okay, so let's try to visualize something about the relationship between displacement or engine size and highway fuel economy. I would expect that as engine size increases, highway fuel economy goes down. Okay, y equals HWY, those are the variable names, so it's going in, pulling out the variable names, very similar to what tidyverse does, and right, hit enter, and we get a nice scatter plot. Cool. Okay, we can also change the geometry that we want to use and do something like smooth. Okay, so now that is a different way of visualizing this information. Okay, so technically the first one just displayed the points. This one's computing something. This one's actually doing some statistical analysis. So it's not only displaying a relationship between the variables, it's expressing that relationship in a statistic that's internally calculated. In this case, it prompted us for what it is in this message, that's using method equals low s. It's using a low s smoother with y as the response, x as the predictor variable. So average highway fuel economy as a function of just displacement as told through this low s smoothing method. And this is something that we can play around with. So for instance, we can do scale equals 2. Wait, what? Do I need to specify that in the aesthetic? Oh, did I get rid of? I did. Okay. What is happening? I know that. Pretty sure. Let me go to the help page. Oh, I always do this. Span. Span, span, span. Okay. Now, right, not in the aesthetic, of course. Okay. Now you can see that this is becoming more and more smooth as I increase span, and it's becoming more jagged as I decrease it. So this is actually doing something to how the statistics under the hood are computed. I should note that the blue line is considered the mean highway fuel economy, and the solid gray that surrounds the blue line is an estimate of the variation. Okay. All right, so let's just go back to the default. Okay. So one nice thing about ggplot for visualization is that I can, so let's say I have this smooth relationship just at the defaults that I'm displaying here. I also have the scatter plot. Well, I may want to display both of those sets of, or both of that information all in one plot. In ggplot, it's very simple because I can just layer everything. So let me do that. So I'm going to create a new command here, copy all of this. Okay. Ta-da. So now I have a scatter plot, and we can see a smoother on top of it. So we get some nice information for visualizing this relationship. Okay, so I have a bit of redundancy here because I've specified these mappings twice. I would like to be able to do that in one spot. And what I can do to do that is in the top of the layer, the top layer, where I specify data, I can also specify a global mapping so that both point and smooth will be performing their operations. Both these geometries are performing their operations with respect to the mapping that's specified. This would be the default mapping for them unless I change things. Okay, so nothing changed. Okay, great. So now I may want to change colors. All right, so no. Let's go back to the data. How about I do it for transmission? Yeah, that sounds good. So, okay, what do I need to do? I need to get trans. Okay, oh, that's a lot of transmissions. I don't want to do that anymore. Let's do drivetrain. Okay, so I've specified an aesthetic mapping globally. This is a lot of stuff, right? It changes the colors for the points corresponding to the different drivetrains. This is four-wheel drive, front-wheel drive, rear-wheel drive. But it also, so it changed the color of the points. It also broke out the smoother across these, across the different levels of this factor variable. I'm going to refer to it as a factor variable, yeah, which it is. Okay, so I may not want that. I may just want a global smoothing relationship while having the different points, different colors. Okay, so what do I need to do? So I've specified this globally. Let's get rid of it here. Actually, no, let's keep everything. Let's just go down the line. Okay. So let's get rid of that. Okay. I want this. I want to change this. So let's specify a new aesthetic mapping AES. Oops. Geez. Color equals. Let's see what that does. Oh, wrong place. There we go. Now I have my smoother globally, but I have different points for the different drivetrains. Okay, one thing, so I'm kind of just picking variables and working with and trying to visualize something that may look interesting, and I don't know too much about cars, but one thing that is interesting here is that we can see this little uptick in the relationship between average highway fuel economy and engine displacement, right, as the engine gets extremely large. And we note that some of these points, most of them are blue for rear wheel drive. And so what I'm guessing is that these cars are just really big engines, really small cars, that these are probably sports cars of some kind with this sort of feature. So if you think that a big engine is needed because the car itself is big or heavy, just to move it along, in this case we have sports cars where the cars are smaller and thus are getting larger fuel economy on the highways. I can do the same thing plotting city, and it looks relatively similar pattern overall. Okay, all right, great. Okay, so let's go down a line, go to our cheat sheet. So this is just 2 geomes. Okay, a little bit about aesthetics, geomes. Okay, so over here we can see what to do in plotting 2 variables, both continuous. Okay, so we did some geome smooth. We can also look at, okay, let's look at geome density 2D, for instance. Okay, so what am I doing? It's per gallon, data set, global mapping. Let's just change this. Just do something new. Okay, cool. We can do a density plot. And so this is displaying where the bulk of the points are in this 2-dimensional space across these 2 variables, and you can see how the points cluster. So maybe that's interesting with these 2 variables, but it's definitely something you can do in ggplot relatively easily. Okay, so we also have stuff for 1 variable. Okay, so let's just display that real quick. Data equals MPG. And I'm just gonna go back to putting the mapping in the geome directly. The most common plot that might come to mind is a histogram for this kind of thing. So let's say AES X equals highway. Okay, cool. We can also do density. Nice. All right, sweet. So we're kind of knocking this off. All right, so stats, alternative way to build a layer. In my experience, or, you know, I wouldn't bill myself as a ggplot expert. It's definitely something I use for visualizations when I write my papers, and I find it extremely useful with this layering, and can, you know, kind of mix and match and try to get my plots to do precisely the right thing that I want. What I typically have found is that, say, okay, actually, let me just demonstrate the point here by going to the help function for geom smooth, because this is something that actually does statistics under the hood. I can see here, so geom smooth, the help page, it says, aids the eye in seeing patterns in the presence of overplotting. Geom smooth and stat smooth are effectively aliases. So they both use the same arguments, and you can use stat smooth if you want to display results with a non-standard geom. Okay, so I guess stat smooth is a little bit more general, but in most sort of, I guess, beginning applications of ggplot, there isn't too big of a difference between geom and stat in the case where your geometry actually does some statistical work in it. Okay, so I'm not going to linger on that for too long. Okay, I'm going to skip scale for right now and go to, I want to go to faceting. Okay, so let's bring out this line again. Okay, let's display the plot. Okay, so recall, I'm displaying average highway fuel economy as a function of displacement, where low S smoothing is performing, is visualizing this relationship, while also displaying points that are colored by drivetrain. I should say, actually, before I go on to this, that I should do shape equals drive. Okay, so the reason for this, again, I'm not covering too much on like the theory of visualization here, but one thing that is important to keep in mind is the that color blindness is very much a real issue, and that it looks like the default color schemes picked a very common form of color blindness and red-green color blindness. So when you display things where color is used to differentiate levels of a variable, you may also want to add shape. So I should have done that from the start. Doing it now, sorry for not doing it earlier. Okay, so anyways, okay, so now that I have this, what I can do, so I have points displayed by shape and color to indicate drivetrain, while also displaying the relationship between highway fuel economy and displacement. Okay, so now let's bring in a third variable, or third thing, facet wrap, and display across, what's something that's interesting? Cylinder. Okay, so now we can see different drivetrains, the relationship between highway and displacement across different cylinders. So here, interestingly, okay, so from an analysis perspective, we get high fuel economy with 4-cylinder vehicles and not very large there's no large displacement over here. Oh, actually, you know what? This makes a lot of sense. It's breaking out the chunks because there is a strong relationship between how many cylinders an engine has and the size of the engine. I should have pulled that right out from the start. That's why you get this discrete plot. So it's literally going from 4, and that's like the cut point almost perfectly to 6. 5 is somewhere in the middle here. And then from 6, there's the cut point almost perfectly to 8. Okay, so makes sense what's going on here. I don't really like smoother for this, so we can get it back, or if you like it, we can also get rid of the drivetrain information and display just the relationship between displacement and highway not doing so much, or concerning ourselves with the drivetrain. Okay, so that's pretty interesting. Okay, so let's see, let's continue on. Okay, so let me go to themes real quick. Okay. So we can add a general plotting theme to this. I really like minimal a lot. Again, we're really not covering too much on like the theory of visualization, but from what I've read, a lot of the theory of visualization says to get rid of as much irrelevant plotting information as possible and strip it down to the absolute bare minimum, of which this theme minimal does an excellent job of doing. Okay, so here you can see, if I get rid of theme minimal, go back, that we have all this like gray background noise and that the axes are in white. A lot of that is just irrelevant information that is just overload. So let's just get rid of it all. Theme minimal. Okay, looks good. So here we can see, let me go back. Yeah, there's nothing in this plot that indicates that I'm breaking it up by cylinder, at least graphically. So it's not the best. Oh yeah, and theme allows you to actually customize your own theme. Okay. Now, labels and legends. A lot of this is self-explanatory, but we'll add a little plot here. Labs. Title equals highway fuel economy versus displacement. Cool. Probably should capitalize the first letter or the title of the plot. And then I think it's got this cool, subtitle. It's kind of fun. So let's do it. Subtitle equals, what do I want to do? Broken up by number of cylinders. Nice. Cool. Okay. Nice. So that's a pretty good graph. And then what else do we want to do here? Coordinate function. Coordinate function, coordinate. Okay. Oh, that's cool. What happens if I do this? You know what? I don't want to just mess with it. I like this plot. I don't want to mess with it. Okay. Plus chord polar. Cool. So that switches the plotting of it quite a bit. Okay, so what do we have? Geom followed by coordinate, facet, scale, theme. I think you can do these in different orders and it does the same thing. So it's not too big of a deal as far as like how you define the layers, but I like I like how it actually gives it. So you have your top layer being the data set that you're going to use and any mappings that you want to define globally. And then the specific type of plot that you're trying to make, the specific geometry, and then how do you want the coordinates of that plot to be viewed. Then how do you want to break that plot up by different discrete levels of different discrete variables, and then what theme do you want at the end? I haven't covered scale yet. Okay. So it's kind of like getting more and more specific as you go out. Okay. This is kind of cool. So we have displacement going around, highway fuel economy going away from the center, and the smoothing relationship is not easy to visualize. So let's actually just get rid of that. Okay, cool. Okay, so yeah, let's get some scale information. You know what? As cool as this polar coordinate plot is, actually, I do want to see what it looks like without the minimal. Not as good. Okay, let's bring this one back, and then we'll do scale. Okay, so let me go to the cheat sheet. Scales. Okay, I don't want to do bar plots. Plot X on log 10 scale. Okay, let's do that. Okay, let me see what this looks like. Okay, good. And what's the order? Scale comes before theme. Scale X log 10. Did that do anything? I guess a little bit, yeah. Okay. So it changes the scale of the x-axis. I bet I can do scale y. Yeah, but it doesn't really change. Didn't really change the axes themselves. Okay. That's kind of annoying. Yeah, it does. It is actually doing the log 10 transformation, isn't it? But it isn't changing the axes. Whatever. That's nonetheless the scale function. Okay. All right, so we have covered a fair amount of information about ggplot. You know what? I should actually do one more thing with discrete variables before I end this. Okay, let me do. Okay, miles per gallon. I think it's bar plots. And let's do cylinders. Okay, so we can do bar plots. Man, it's jarring to see it. Okay, a little bit better. We can go into this and remove all of the axes lines if we want. I'm not going to do it, but that's something that we could do. I don't know all of this off the top of my head. ggplot is, I should say, ggplot is massive. Data visualization is massive. These are massive topics. I probably should have started by saying this. And so that there are entire books on ggplot and on data visualization, and we're just kind of scratching the surface right here, but going through enough basic information so that you have a solid foundation for when you want to do I guess convincing visualizations using this and understanding how sort of like ggplot works with the layering to get more and more precise and descriptive and powerful visualizations relatively fast through the layering. And I should also say that base R, which we've covered a lot of programming concepts in so far, has its own plotting system as well, but that plotting system is just, in comparison, very, very cumbersome. Okay, that all as an aside, bar plots. Okay, and I wanted to go to scale. So let's see here, bar plots, scale, geom bar AES fill equals. All right, sorry about that. My baby was coughing, so got it for a little bit. Okay, so back to bar plot. Okay, so I was at here, AES fill. So I'm gonna actually, you know what? Let's do mapping equals AES X equals cylinder. I want this globally. I don't want to get bogged down here. Okay, same plot. Now I'll do AES fill equals cylinder. Oops, sorry. Okay, so I can fill the bar plots by different variable. Let's do fill by displacement. What? Is displacement? Oh, displacement's not a continuous, or that's a continuous variable. Whoops. Yeah, fuel economy, okay, that works. So what was this variable again? Okay. Actually, FL, fuel type. All right, cool. But anyways, you can see how I've broken up the bar plots to display the amount by these different fuel economies across the cylinder levels themselves. Okay, so that's something that we can do with this in this scale section here. Okay, very cool. Okay, so very, very powerful ggplot. We can do a lot of stuff. Okay, I'm starting to ramble and trail off again. Okay, so let's summarize. Okay, so the basic structure is that we have a top layer where we specify ggplots to create this new canvas plotting environment with a data set in mind. Then we have a different sort of geometry for how we want the information to appear, like a geom point for scatter plot, geom smooth for a smoothing relationship between the variable. Of course, we can combine these. Bar plots for displaying counts for factor variables, so forth and so on. Then we can just specify a coordinate system. We can consider faceting for displaying the relationship across several variables, different scalings, and of course a theme at the end for changing around the overall presentation of the visualization, in which case I demonstrated theme through the minimal theme, which stripped away a lot of the what I would say useless gray background colors. Okay, so then within that general template, there is a lot of information, which in ggplot, of course, generally, but even on this cheat sheet, which we sort of have touched upon. So, and you can see that even with just kind of picking and pulling things off of this cheat sheet, we were able to create very powerful plots. Remember, we started here, which is a simple scatter plot between visualizing the relationship between highway fuel economy and displacement, and we ended up with something like this. So in a few short steps with our handy cheat sheet at our side, we're able to do a lot. Okay, so I'm gonna stop here. Again, this just scratches the surface of ggplots, but that being said, we're able to do a lot with, or we can create some pretty powerful plots just with that simple amount of information presented in this cheat sheet. I encourage you to read the data visualization, where it also goes through ggplot from the ground up, but with a sort of targeted goal on creating this kind of plot. Okay, and you can kind of see some of the stuff in here that we've covered, right? We want a relationship displayed globally, although we want to display different, or we want different colors across and shapes across a factor grouping, so you kind of already know what to do. I would say, even though this is the goal, I would get rid of this gray background and do theme minimal or something like that. But anyways, all right, I'm really starting to ramble now. If you made it to the end of the video, thank you so much. Take care. I'll see you next time. All right, bye.